We need to talk about the biggest breakup of all time, the breakup of the supercontinent Pangaea. Around 200 million years ago, the ground split open, and the crack grew until it reached all the way across the supercontinent, eventually flooding with seawater. This seaway connected two ancient oceans together, separating Laurasia in the north from Gondwana in the south. And it also separated all the plants and animals that lived on each. This was a major fork in the road of evolution. Life became divided into two different groups. But they didn't lose touch forever. The subcontinent of India became a sort of island messenger between the two halves of the globe, breaking away from Gondwana and traveling 9,000 kilometers across the sea to collide with Laurasia. This journey took 35 million years, but the plants and animals that went along for the ride when India became an island eventually reunited with their long-lost northern relatives. Kind of. Because a lot can happen over that much time. And ultimately, when India smashed back into Asia, it really just traded one form of evolutionary isolation for another. When the breakup started, Gondwana was made up of what is now South America, Africa, India, Antarctica, and Australia. Africa, Madagascar, and India were once neighbors. That is, until sometime around 120 to 100 million years ago, when a rift formed, breaking India and Madagascar away from Africa and isolating all the Gondwanan plants and animals living there. Then, around 90 million years ago, Madagascar split off and India was basically on its own. Now, we know that island isolation often leads to unique evolution. Think of the Galapagos, or Madagascar itself for that matter. This is allopatric speciation, where a physical barrier creates a separation that leads to new species. And during the Cretaceous period, the island of India was home to a bunch of animals that were suddenly cut off from the rest of the world. Everything from frogs, lizards, turtles, snakes, centipedes, and crocodiles, to plant-eating sauropods like the gigantic Jainosaurus, and meat-eating theropods like the two-legged Indosuchus and Rajasaurus. There were even early mammals like Gondwanatheres, an extinct group that looked kinda like big rodents. But Cretaceous life on India wasn't all an island paradise, as the subcontinent was just beginning a wild tectonic ride. When it first broke away, it was traveling at around 5 centimeters per year. That's already pretty fast. Today, the average plate moves at around 1.5 centimeters per year. And India was so fast because it's very thin, only 100 kilometers thick compared to other plates like Africa at 300 kilometers. The gigantic plume of hot material that had emerged from the mantle and caused the initial breakup of Gondwana had also melted rock off of India's base. And then, 80 million years ago, the plate accelerated to a sprint, moving at a rate of over 14 centimeters per year. This is because it was being pulled by two parallel subduction zones, where one plate slides beneath another and sinks into the mantle. One of these was in the middle of the Tethys Sea, and the other was along the coastline of Laurasia. Because they both pulled in the same direction, like two people on the same side of a tug-of-war, this yanked India northward exceptionally fast. India then sped through different climates, putting pressure on the plants and animals to adapt to new conditions or perish. Around 67 million years ago, the plate began to slide over the Reunion hotspot, fueled from below by a massive plume of magma. And the force of this plume beneath the Indian plate sped up its pace even more. It also triggered a massive volcanic eruption known as the Deccan Traps. This was a flood basalt. Erupting lava literally flooded the Earth's surface. It poured out enough lava to cover an estimated 1.5 million square kilometers, an area the size of Mongolia. This amount of lava could fill the Great Lakes nearly 50 times over. Today, the remaining basalt still covers 15% of modern India. And this volcano came at the worst possible time, because one of the main eruptions lasted 700,000 years and began just 300,000 to 400,000 years before the Earth was hit by the asteroid that led to the Cretaceous-Paleogene extinction 66 million years ago. And while the Deccan traps didn't cause this extinction, many scientists think they played a big role in worsening it. The eruption spewed out toxic gases like mercury. It also released aerosols that spread out in the atmosphere, reflecting sunlight and suddenly cooling the planet. But when these cleared, the carbon dioxide released by the same eruption also warmed the planet over the longer term. The temperature had come back down by the time the asteroid hit, but this roller coaster of climate meant that life was already under incredible stress. And in addition to feeling these global effects, life on the island of India also had to contend with lava flows and nearby volcanic gases. Living basically right on top of the Deccan traps meant that the effects of the mass extinction were amplified. Nearly all vertebrates were wiped off the subcontinent. The few survivors included frogs, snakes, and caecilians, the worm-shaped amphibians. All of these can burrow into the ground for protection, so that might have been the key to surviving both a massive volcano and an asteroid impact. After the dust settled, there's about a 10 million year gap in our understanding. Paleontologists just haven't found many fossils from this time in India. So we pick up the story again during the Eocene, around 55 million years ago. And the fossils from this time make it clear that the island of India played an important role in the evolution of placental mammals. But where did these mammals come from in the first place? One idea is that they could have originated in Gondwana and survived the Cretaceous-Paleogene extinction in India, known as the Out of India hypothesis. But most scientists disagree. See, India broke away before mammals with placentas evolved. And since the vast majority of modern mammals, including all modern Indian mammals, have placentas, the ancestors of these mammals would need to have somehow made it to the island of India. So researchers think that despite being in the middle of the Tethys Sea at the time, it's more likely that India wasn't completely isolated. As the subcontinent neared the Asian mainland, but before it had fully docked, some animals were able to migrate from the mainland to India. They likely did this by hitching a ride on floating objects or jumping between smaller islands like stepping stones. And once these mammals made it, ancient India was home to some big evolutionary milestones. In fact, both horses and whales can trace their roots back there. For a long time, the evolutionary history of ungulates, mammals with hooves, wasn't well understood. See, fossils of both groups of ungulates, those with an even number of toes and those with an odd number, appear suddenly across multiple continents. So where they came from in the first place has been a big question for a long time. And a study from 2014 describing a 54.5 million-year-old fossil of Cambatherium in India provided an interesting clue. This was a genus of four-legged herbivores that was an ancestor to the order of Perissodactyla, the odd-toed ungulates. Today, this order includes horses and rhinoceroses. So this entire order could have originated in India, as it was nearing a collision with Asia. But what about the even-toed ungulates, called artiodactyls? This group includes pigs, giraffes, and camels, as well as whales and dolphins known as cetaceans, who evolved from land-dwelling mammals. And Indohyus was one of these mammals. Indohyus looked kind of like a deer with a long nose and thin limbs with hooves, but it was around the size of a cat. Its fossils have been found almost exclusively in India and Pakistan, suggesting this is where cetaceans made their transition from land to sea during the Eocene. And each stage of this transition can be seen in Indian fossils. That is until 49 million years ago, when the protocetids, a group of extinct cetaceans, evolved. Then suddenly their fossils appear all over the world. Cetaceans had gained the ability to spread out from the island across the world's oceans. Their ability to swim gave them a head start in terms of spreading out from India. But the collision with Asia provided a burst of new land-based species in both directions. India fully established a connection to the mainland around 45 million years ago, which is when we see plants and animals begin migrating both out of and into the subcontinent. One of these groups was the dipterocarps, a family of trees that can grow to over 50 meters tall, and today dominate Southeast Asian rainforests. They originated in Gondwana during the mid-Cretaceous and were carried across the sea by India. And some animals, like the ungulates, originally came from Asia but continued their evolution on the island of India before dispersing out again. Others, like the blind snakes, centipedes, and caecilians, first originated on Gondwana, survived the mass extinction, and diversified in India before spreading out across Asia, after a very long ferry ride. And the rate at which species migrated back and forth from India to Asia continued to increase until 15 million years ago. Because while India's isolation and journey across the sea was a unique tectonic moment that led to the evolution of equally unique animals, it wouldn't be the last time geologic forces isolated India. Its collision with Asia built the tallest mountains in the world, the Himalayas. And just like oceans, mountains create barriers between groups of species, allowing them to evolve in isolation.